Hi, I am Anakumar. Welcome to KEEL Data Mining Tool presentation. KEEL stands for Knowledge Extraction Based on Evaluationary Learning. The most popular tools are Rapid Miner, Weka, Orange, and Nine. These are all the free software, free licensed software. Why we need? The main question is why we need to choose this tool. It supports large library with evaluationary algorithm, and also it supports statistical test for comparison, and it supports online execution and also supports post processing. First we see how to install, then we move to explore the tool.
www.keel.es. This is the website of the KEEL software tool. We can observe so many options are here: description, download KEEL software tool, reference manual, and the KEEL data set, KEEL included algorithms. For downloading, go to download KEEL software tool. Here we can observe two options: one software source code and another is jar executable files. These are the jar executable files and these are the source code. If you download this source code, you have to execute. Better to go to the jar executable files. These are the previous versions of the KEEL software tool. Better go to the jar executable file. It is downloading. For checking the system requirement, go to the reference manual. Here you can see the introduction of the KEEL software tool. This is the website of the KEEL software tool. System requirement. JVM 1.7 or more versions are required to execute this GUI tool. This tool supports various formats. You can observe CVS, TXT, PRN, DF, C4.5 and Excel, Weka, XML, HTML, and the KEEL data format is DAT format. KEEL dataset repository. This tool supports more than 600 datasets. These are the type of problems: supervised classification, semi-supervised regression. These are the data sets available for particular type problems. For your problems, download the data sets and experiment with that. These are the format of the KEEL software tool dataset. The relation, name of the dataset, attributes, input, outputs, and data. These are the standard classification datasets. You can download the datasets or already preprocessed. These are the already preprocessed datasets. These are the type of data. These are the datasets: banana, Titanic, and Iris. KEEL included algorithms. It supports lot of algorithms: data preprocessing algorithms and the classification algorithms and the regression, imbalanced, semi-supervised, and the statistical test. Disaggregation, 30 algorithms are there. If you want to see the algorithm descriptions and algorithm, this is the full name of the algorithms and the short name, which is referred in the GI tool, and the references. You can see the full description of the algorithm. Just click which algorithm you want to refer. Just click on it. It's downloading. Just open it. Next time. So go and start it now. Flow charts and the algorithm details and how it works, everything given in the full description. These are the disaggregation algorithms. You check all the algorithm details here. Links for further reference. Further reference, you can check in links and the identification access. After downloaded, just click on it and extract where you want to execute. You can extract anywhere you want. Just click extract files. I choose the D subdirectory. After click OK. Okay, it's progressing. Since it's to all, auto remove it's to all. Go to D subdirectory. It is extracted as a dist folder. Just search the dist folder, click on it. You can observe the three directories and one jar executable file. Algorithm consists of the algorithms jar files. This is the method, post process, and the pre-process here methods. These are the algorithms jar files, and the post process and the pre-process same jar here consists of the jar files are here. Data, some of the data sets already included, some of the standard data sets available. If you want to include some more data sets, go to dataset repository and download. This is the jar executable GUI. Just double click on it. It opens the GUI of the KEEL tool. Here, this is the GUI of the tool. Management, experiments, educational, help, and modules. Data management module is used for pre-processing dataset before using in experiments. Experiment section used for designing experiments of data mining problems, and educational Educational module is used for teaching purpose, and the help module for reference, and the modules here this module is used for same as experiment. It handles the unstructured data sets. Go for data management first. So stat here these are all the options are provided here. Same options are here. And for import data imports the other file format to KEEL format. So there are two options are available: import dataset and import partitions. If dataset already partitioned, go for this. Otherwise, choose the import dataset. Next, and choose the format. Formats are available here. CSV form. Here the formats are available. KEEL to CSV, CSV to KEEL are. These are the formats supported. So I am importing CSV file. Choose the file and go for next. It is imported. This is the original file .csv format. This is the imported the KEEL format. Attribute and instances here. Relation vehicle and the attribute compactness and the type integer and from the range of 73 to 199. You can observe these are all the instances. Here if you uncheck it asks for location where it want to save. Otherwise it's saved to the import section. So better to save for further purpose. So import to the experiment section, save. I give the name to save vehicle 26. It says okay. Select the type of problem. So I choose for classification purpose. Do you want to edit this data set? So if you want to edit, so press yes. Change the data set. So just click on it. Here shows the range 33 to 59. You can give any range from this. I give 45. So it changes. If you want to add instance, just give add instance. If you don't want, just delete instance. Is the variable description. So variable name, type, range, and the input or output. If you want add variable here. So go to stat, export data. Here from KEEL format to other format. So the same as previous. So just click next. Here select the KEEL format. So KEEL. Vehicle KEEL format .dat. Just click next. It is imported. So exported file .dat. So it export to the CSV format. Just save. I saved here in this location. Just save. Okay, it's saved. Go to start. We want to visualize data. This option allows you to visualize existing KEEL format data set. Visualize data. Just load the data set if you want to visualize. So vehicle.dat. Open. You see the attribute relation vehicle and the attributes and the instances. Attribute info. This gives the attributes and the type and the functions. Functions are input or output. The type. So just click on it. You can see the graph information of that data. So charts 2D. You can compare two attributes here. Just give the two attributes and just compare it. Compactness and reduced. View chart. You can observe the chart here. You can export to the convert to PNG or convert to PDF format. Stat. Edit data. edit data. So it is already loaded. If you want to load another data sets, just click on this. Just click on this button and select whichever you want. So air quality.dat, open. It opens. So these are the variables and these are the data. If you want edit it and save it. And just give the range also. Value rank and the range you can observe here. If you want add instance or delete instance here. Variables, attributes, types, range and input or output. Go to start. So make partition. You can select the file for partition. So there are 3 partitions are available: k-fold class validation, 5x2 class validation, k-fold distribution, optimally balanced static satisfied class validation. So k-fold class validation takes the seed, and if you want to divide, just give the divide. So where you want to partition, so I choose the location here only, so save it. So your partition are going to generate the process, press OK to continue creating partition. OK, your partition have been correctly generated, so you can check partition over there. So in k4 class validation, k-1 sets are the training sets, the remaining is the test set. Go to stat. So help data management section. This for help data management section. So it finishes data management section. Experiment section. Experiments, k-fold class validation. The type of partitions. These are the type of partitions. I choose the k-fold class validation. Here you have to give the k value. So then you have to choose the type of experiment. Type of experiments are here: classification, regression, unsupervised learning, and subgroup discovery. I go for classification. Here you have to select the data sets. The first part is choose the data sets. These are the standard data sets already included in the GI tool. These are the user data sets. You can add any data sets or input. I choose class and the high-risk data set for my experiment. After choosing the data sets, just click on this white area. So data module included. Here all the other modules are activated right now. This is for selecting the modules. This is for pre-processing. These are the pre-processing algorithms: data complexity, desensitization, and evaluationary feature selection. Data complexity, desensitization. I am choosing from evaluationary training set, CHC and TSS algorithm. After, I am choosing the standard methods for solving determining problems. I am choosing from lazy learning, KNNC algorithm. After, check post-processing. This is for post-processing. This is not available for my experiment. And this is for statistical test for classification. I choose the class Friedman aligned ST algorithm. The finally Azure class. This was show results for classification with class check algorithm. Finally, connect all the algorithm from data to CHTSS for training set selection. Pre-processing. This is the pre-processing algorithm. After connect to the standard methods. The finally standard methods to class Friedman aligned ST, and finally standard methods to this class check. If anything connection wrong, it generate the error messages. Just see. it generates the error. Wizard inputs only can methods are post process. Okay. After designing the experiment, just save it. Save experiments wherever you want. Save it. Just give the name design 1. Save. It's saved in XML format. So after run the experiment, just zip full. Run the experiment. Give the name ESI. So I saved it. It's saved in zip format. Just save it. It gives a notification. We have to unzip the generated file. Then go to the desi/script directory and finally execute from command line java -jar run KEEL.jar for running this experiment. Just click on OK here. Go to where it is generated. So scripts, documents, DESI. So unzip this folder. So unzip, extract here. Focusing, unzip DSI here. There are 4 files. There are 4 directories are here. Here included all the required executables are available here. So these are the data sets: glass and the iris, and for converted form, and the exe files. These are the algorithms executable. Files, and the results. For after executing, we can check the results here, and finally scripts. We have to execute this run KEEL.jar. After executing the experiment, we can observe from result directory. So here now we can see results are not generated. After executing this experiment, we can see the results. All directory are empty now. Go to command prompt cmg. Okay. Just copy this location desi/script. Copy the location. Control C. CD. Just paste it. For executing, java -jar run KEEL.jar. Now experiment runs. Reading the data is just observing instance rate. So from one input to after processing the one module, just gives the input to another module. So just that gives the notification file loaded correctly and all those things. File loaded correctly, yeah. Here the experiment. So finally we can observe finishing the experiment. Executing, finish. Yes, end of the experiment. Experiment completed successfully. Now result generated in result folder. You can observe the result. Yes, DSI results. So CHS RSS. This is the Friedman aligned ST output, and this is this class check output. And you can check training set selections. This is the pre-processing algorithm for both the data sets. This you can observe the result. So knc.c. So output, this is the output, and the for both the data sets you can observe here. So open this folder. You can see for first data sets output. Open with Notepad and Microsoft Word. You can see Microsoft Word. Fragment test classification. So algorithm KNNC fold we already specified 0 to 9 is a 10. Classification error in each fold. So this is the errors observed in each fold, and the mean value finally we observed here. The same result for second data set. So finally we can say this output. One with and Notepad. This is the output of the Friedman aligned ST. So with class check. This is for first data set output. Open with more options. Open with Microsoft Word. Test result classifier. This is for test result. 10 folds are here. So this is correct probability and this not correct. Finally, the global classification error plus not correct probability and the correctly classified. This is for train result. Same output here. Classification error plus non correct. Correctly classified and the global not correct. This is for resulting. Once you design, you can run. So you can run the design any machine with a JVM installed machine. This finishes the experiment section. Educational module. This module is used for teaching. It is running on online mode. Education. First we have to choose type of partition. So K4 cross validation, K4 DOBSCV, parental cross validation. I choose K4 cross validation. This is the fold value. Then we have to choose type of experiment. I choose classification. First we have to choose data sets. I choose from KEEL data sets. I choose 2 data sets for my experiments. Then we have to click here. Now data module included our experiment. Then we have to choose preprocessing algorithm. I choose from training set selection ENN TSS. Click here. Then I choose from standard methods algorithm. I choose from decision tree C45C and click here. Finally connect the graph through connecting. Then save the experiment. Save experiment. Give the experiment name design 3. Save. It saves in XML format. Then you can run the experiment. So we can observe 3 options here: start, suspend or resume, stop. Press the start button, experiment will run. Start. You can observe the initial time and progressing. So each time for fold partitions. This is for first data set. Progress finishes, final time and the run time. This is for the first data set, partition 1. partition 2, up to partition 10 we can observe here. This applied C45 algorithm. This is for training set. Percent of success 0.765, and the percent of success in each partition we can observe here. And this is the confusion matrix based on training set. This is for test set, total percent of success and the percentage of success in each partition. And this is the confusion matrix drawn for test set. Can observe the decision tree. Finally drawn. Total number of nodes 16, number of leaps 17, total number of nodes 16, number of antecedent by rule 5.1764, number of items training, and same we can observe the results here. The same applied for second data sets also. This is the partition 1 to 10 partition we can observe here. Then C45 algorithm applied for second data set. This is for training and the total percent of success and the percent of success in each partition. Confusion matrix. This is for test set. Confusion matrix and decision tree. Same thing we can observe here. Total number of nodes, number of leaps, and total number of nodes. This finishes the educational section. Help. In help model, it gives the description of each module. Data management, experiment, and educational module and modules. Okay. Then finally module section. This module section, it is same as experiment section. So imbalanced learning, this is used for solving imbalanced data. So designing, applying everything same as experiment module. Then non-parametric statistical analysis. This is the extent of statistical test algorithms for applying a CSV format dataset. Semi-supervised learning. This model is used for applying labeled and unlabeled datasets, and multiple instance learning. This is for applying a multiple instance when without repetitions. This is the super kind of semi-supervised learning. So go back. It finishes the demo of the KEEL tool. Thank you.